This video is going to talk about some of the key components that you can see inside of the Hassa diagram of a poset. So first thing is a reminder of the correlation between the actual partial order of your poset and the Hassa diagram. So suppose in your relation you have some ordered pair, x is related to r, or as commonly written, x is related to y here. So either those two ways, the ordered pair or x related to y. Then in the Hassa diagram, here's what you see. So in the Hassa diagram, remember, you still have those arrows behind the scenes, those directed edges back from your digraph, but they all got reoriented. All the little arrows are pointing either directly upward or in an upward direction. The first guy of your ordered pair was where the arrow started. The last guy was where the arrow ends. So x is down at the bottom and y is up there at the top. So this, in terms of reading up the picture, totally matters here. It tells you how your direction is. Now that's going to be important when we talk about our elements. So the first element that we're going to look at is something called the maximal element of your poset. So some guy A of your building set of your poset is considered a maximal element if there exists no element C in your building set such that A is related to C. Now, why would this guy be called maximal? Because if you looked at A in your poset, well, A related to C would mean what? It would mean there had to be somebody above A in the poset, where you literally could follow a line going up all the time and get to C. Well, if there's no such C that can happen, that means following any line going up in your poset, you can't go any further up in the picture in the Hassa diagram than A. Okay? If you think of these as like, I don't know, roads, A is a dead end. Now, lower than A? Yeah, sure. We can totally have some guys lower than A. That's not a problem. But there's nobody that, if you travel lines going up only, that you'll have above A. Now, related to this is somebody called a minimal element of your poset. So I strategically chose here B to be the minimal element. So you have your minimal element B, and its definition is there's not going to be some other element C where what? Well, in this particular case, where C is related to B. Now, again, I think it's much easier to see all this in the picture itself. So if we look at how this would look in the Hassa diagram, if we look here at B, what happens? You can't have anybody C that's related to B. Well, if C is the front one, that means C would be lower than B. So this tells us if you look below C, following the lines only going down, below B in the Hassa diagram, only following the lines down, there's not going to be anybody below B right there. Now, above B, sure, it doesn't matter what's going on above B. Minimal elements here are only looking at elements where if you're looking down in the Hassa diagram, there's no one traveling down or below these guys. Okay. Now, there are last two types of elements that we're going to look at, and they're actually special types of minimal and maximal elements. So the next guy that we've got is somebody called the greatest or maximum element, and the notation, and this is actually common notation, but your book doesn't use it, which is one with a little caret, a little hat on top. So this one represents your greatest or your maximum element, and different books call them different things. Your book uses maximum. So here, an element A is the greatest or the maximum element of your poset. Okay, if what? Well, it turns out in this case, if you look at X is related to A, that's supposed to be true for all X inside of your building set A. So notice what that would mean in terms of your Hassa diagram. If you look over here at your element A, you're supposed to be able to do what? You're supposed to, by way of whatever lines are actually in the Hassa diagram, if you travel down, you'll reach all the other elements in the actual poset or in the relation. Okay? So notice what this guy is. This is actually a type of maximal element, but it's specific that here the definition of maximal element is you can't go up. This one says all the other elements are below him. It does turn out there is a difference between the two. Specifically, when you can have a maximal element that's not also a maximum element, but we'll look at those examples when we get back together in class. Okay. And the last type of guy that we're going to look at is somebody called a least or a minimum element. This one, the symbol for it is a 0 with a little hat or a little caret on top. Again, your book doesn't use a symbol for this guy, but that is the correct symbol for the maximum element of a poset, or if you prefer the least element. Okay. So here I'll go ahead and use a B again. So little b in building set A is considered the least element of the poset if B is related to everybody else in the poset. So if B is related to X for all X inside of your building set A. Now notice from a picture standpoint what this would look like. Again, you focus in on element B and everybody else up here reading up the Hassa diagram, you'd be able to reach every other element in your actual poset. Okay? And that's the crash course on minimal, maximal, least, and greatest elements of posets.